And hello everyone. Today I'm going to be explaining, the systems used in engineering, science, and legal matters for making predictions. It's also called exploratory data analysis. All of this information I have learned from the Engineering Statistics Handbook, which you can easily find on the internet by googling ESH, Engineering Statistics Handbook, which is a document prepared by the US government, often used in engineering and in the aerospace industry. Now, why would we want to do predictive analysis? The reason is because, except in mathematics or in logic, um, we we can never be 100% sure that we are correct. Only in pure mathematics and logical tautologies do you always have 100% correct solutions to problems. So in the real empirical world, we only deal with probabilities. So what we do is we generate data and then we use the data generated to make decisions. And the tool used is statistics. The objective here is to use this method, which is recognized in engineering science and court, to d- make decision with a certain degree of confidence. And the way we do that is by first gathering the data and then we analyze the data, where which is why this system is called exploratory data analysis. So in this example here, what I have is times that commute times. The data here is in minutes. So those are minutes, the number of minutes that it took me to commute from work to home. And each data represents the number of minutes on a different day and using different routes. So you see there's about 200 data points, and these data points are used to generate different types of plot, which is called the 4 plus analysis. And the reason why we use these plots is to determine if the data can be modeled. And we know that if the data is from a random source with a fixed location, fixed variation, and a fixed distribution, then we can use mathematical or engineering model to predict the future data. If any of these conditions are not met, then we cannot make any prediction. Then the data is just random and chaos, and there's no point in trying to predict what it's going to do in the future because you don't have a system that allows you to predict it. So in most cases, actually, most of the data that is generated is it's just historical data. You cannot use it to make prediction. So in this case, we the four conditions are met: randomness, fixed location, fixed variation, and fixed distribution. So that means that we can use our data to model it and make predictions. And how do we determine this is explained in the Engineering Statistics Handbook, but basically, if plot number 3 is structureless, then you know that the data is random. If plot number 1, which is you have here below, is has no trends or the trend line is horizontal, then you know that you're from a fixed location. And if the vertical spread is relatively constant, then you know that you're from a fixed variation. And the fixed distribution, what we are looking for here is if we have a normal distribution. So if we go down to plot number 2 here, we see that the distribution is almost the standard distribution with the standard bell curve. It's not quite exactly it. So but we can assume that we're close enough. So that means that we have data here that can be modeled. And this is our plot number 2, another plot that's used to determine if we meet all the condition. It's a lag plot. The first plot is I made a bit of a mess here. I'm just going to fix that here. This is a plot number 2, fixed normal distribution, and plot number 1, another mess here. So just fix that. This is just a plot of the data of x versus y, where you have like the second column here is the first column but delayed by 1 day. So that allows you to see the structure of the data. So um, now that we have determined that the data is predictable, then we can use it to make decisions. And in this case here, I'm using the data to just zoom out a little bit here. There you go. I'm going to be using the data for deciding which is the best bridge for me to take to go home, depending on the time of day that I'm leaving. So you see we have here 5 different options. The Jacques Cartier Bridge, the Victoria Bridge, taking Henri Bourassa, which is like just one long straight street north of Montreal, and then taking the Jacques Cartier Bridge. The other option here is the Champlain Bridge, coming from the west or coming from the east. Champlain B is coming from the Bonaventure Autoroute, and ME is the Mercier Bridge, another bridge that is a bit farther, but that has the data is not showing here. I need to fix that. Anyway, so uh, this box plot or a candlestick plot gives you an idea of what is your best option depending on the time of the day. So for example, if I leave before 4 p.m., the Jacques Cartier seems to be the best choice. And if I leave after, actually, like here, conclusions here. So these conclusions, now that we know that we have a system that is predictable, we can use it to decide which is the best option. And in this case, depending on the time of the day, that's part of the model. I'm not going to go into those details, but the recommendation is to take the Jacques Cartier Bridge if I leave before 4, and take the Victoria Bridge if I leave after 4, and yep, that's it.